Good evening. Welcome to Left, Right and Centre. I'm Vishnu Shom. On the programme tonight, as the Prime Minister heads to the United States, he leaves at about 7 a.m. tomorrow. We bring you on this programme a deep dive into two deals which, when signed by the Prime Minister and the American counterparts, will redefine Indian aerospace and also redefine the operations of our armed forces. The first is a deal to transfer jet engine technology to India. The other is a deal for drones. We'll be looking at both of these deals on this program. But first, jet engine technology is widely considered the holy grail of aviation tech. Very few countries have it. Everybody wants it, which is why the US decision to transfer key engine technology manufactured by General Electric to India will be a landmark deal. Jet engine technology, widely considered the holy grail of civil and military aviation. This is the General Electric GE F414 engine, a cutting-edge jet engine that powers the F-A-18 Hornet, the US Navy's go-to fighter. This engine may now be produced by General Electric in India. In a multi-billion-dollar deal with Hindustan Aeronautics, with reports suggesting that America is willing to transfer key technology worth up to 80% of the value of the deal. It would power the LCA Mark II, an advanced variant of the Made in India Tejas fighter that you see here. The United States has never allowed the transfer of this level of technology to anyone. State-of-the-art jet engines include components which are deeply intellectual property rights protected, with manufacturing processes that are top secret. The technology that India may get includes coating and machining of single crystal turbine blades. What exactly are we talking about? Consider this. Manufacturing components of jet engine turbines has always been a massive engineering challenge through the history of aviation. Jet turbines need to retain their shape, their strength and their efficiency at temperatures up to 2000 degrees centigrade. Metal alloys used in older jet engines using conventional manufacturing techniques failed at the highest temperatures. They lost their thermal efficiency, which is why a handful of companies began to develop what they call single crystal turbine airfoils. Through profound chemical engineering of superalloys, single crystal turbine airfoils are able to achieve 3 times more engine life protection against corrosion resistance. Far lower overall weight. It's a lighter engine. A higher melting point temperature. This is absolutely critical. And massive engine life, much more than usual, up to 25,000 hours before an overhaul takes place. For India, the deal will mean that GE will open shop in India in partnership with HAL at a new plant to introduce the manufacturing processes required to build not just single crystal turbine blades, but also other key components, including laser drilling for combustion, machining of powder metallurgy, and the manufacture of compression discs and blades. The GE 414 IN6 engine, when it's built in India, will power not just India's indigenous Tejas Mark II fighter, but also the futuristic AMCA, or Advanced Medium Combat Aircraft, a stealth fighter. For the Indian Air Force, this will mean reliable and long-lasting jet engines. Russian engines in the past frequently needed an overhaul at a few hundred hours. Now you have engines which can be overhauled after several thousand hours. Engines which are lighter, more powerful, much more fuel efficient, and with the potential to be upgraded for future use. The benefits of all of this will be transformational for the Indian Armed Forces. Vishnu Shom for NDTV. Well, we've got a fantastic panel this evening of some of the finest experts in aviation, pilots, engineers, others on this program. But first, let's go straight across to Air Chief Marshal RKS Bhadoria, the former Chief of Air Staff. He's been a test pilot himself. He knows the Tejas program besides anything else inside out. Thanks, sir. Wonderful to speak to you. In simple terms, when this technology comes to India, what does it potentially mean for Indian aerospace?
This technology transfer, the way and the extent which is coming now, it's a very big step. I think it is unprecedented in terms of the depth of technology transfer. I'm aware of what was on offer a couple of years back. So this is absolutely unprecedented. And what it will do is, in the manufacturing setup ecosystem for a modern engine like this, it will be a huge step to set up this ecosystem, both not only in HAL but the private sector, which is very, very important if we have to really capitalize on diversification into private sector and bring in efficiencies. So this is a huge step, and it will set up in the engine domain what LCA did in the airframe and the fighter aircraft domain in our ecosystem. So it is a very, very important and big step.
Sir, this is going to be a deal which Hindustan Aeronautics is going to be involved in with General Electric. Do you believe that in the future, perhaps there needs to be private sector involvement as well?
No, I think let's look at the project itself. We are talking of 300 to 350 engine upfront, although initial talk is about 100. But we are talking of Mark II, we are talking of AMCA Phase 1, TED-BF will have. So 300 engines straight away with the float goes to 350. You take life cycle, we are talking of 1,000 engines. A project of this cost and these numbers, we should straight away have a very big private sector participation. And it is very important to set up this ecosystem in a very organized manner throughout our areas of domain where this capability exists, both in DPSU and private sector, so that we can diversify, we can bring in those efficiencies and be able to scale up. We should remember that the whole effect for it to engine the Mark II and AMCA quickly, we would need to be in a position to scale this up very quickly. And private sector participation is very important. In fact, I would think that private sector participation in the manufacturing upfront with HAL as SPV or something, even that would be a very good solution for a project of this size.
Yeah. Sir, you know, as a fighter pilot yourself, you've flown the entire range of fighters in the Indian Air Force. You've flown MiGs, Mirages, etc., etc. Russian engines, which we've relied on so heavily in the past, have had low life cycles. They've had to be overhauled very frequently. And for operational planners, that's difficult because you've got aircraft on the ground and not on the air when you need them. If you now have this sort of technology coming into India and it is reliable and it has higher thermal efficiencies, what does it mean for the operational planners of the Indian Air Force?
Well, this makes a huge difference. 404 and 414 by design and what we have seen its operation on LCA Mark I. It is very robust, very safe. It has given us virtually accident-free performance till now in the entire LCA project, which is huge. And the life cycle that you mentioned, the time to overall, the level of modularity, the kind of technology involved, particularly the single engine crystal that you mentioned. So all this goes into improving reliability, safety, and a very long life cycle. So from Air Force perspective, from maintenance, from sustenance, from the cost of sustenance, it is, I think, very important to have an engine of this kind into our Indian Air Force.
And sir, bottom line is that this and its future avatars, if built in India, would be the bedrock of engine technology, jet engine technology used by the Indian Air Force.
Absolutely. This is a very modern aircraft, very engine, very capable. So once we set up the manufacturing base with this level of technology transfer, virtually it is everything, you know, except for maybe single engine crystal. I don't know whether casting is included. I didn't see that in the list. But overall, I think it will set up a ecosystem of manufacturing a jet engine of this class into the Indian aviation industry. Which would be critical when we go to the next step of having our own engine as a design or as a cooperative design, whichever route we take. This ecosystem of manufacturing is required as step one. So it will do a huge, it will be a huge advantage for our aviation sector, particularly to support the fighter engine programs. And also in future, just remember AMCA 6th generation, we are going into optionally manned. All these aircraft will need engines like this. So while I said 1,000 engines, truly speaking, actually the numbers would only go up. It will not come down.
All right. Sir, thanks so much for joining us. Air Chief Marshal RKS Bhadoria. it is a wonderful step, and it'll ultimately help towards Atmanirbharta in India as well, because its spin-offs would be absolutely big for the indigenous industry. Thanks so very much for being with us. In fact, I welcome you to stay on. We're joined by two people who you have worked with very, very closely. Somebody who served under you in the Indian Air Force, Samir Joshi, and somebody who you've know all too well, sir, as a former super test pilot of the Tejas aircraft, the first pilot to land on the Tejas on an Indian aircraft carrier, Commodore J. Maulankar, not too recently with the project, retired quite recently. I'd like to thank you both very much for being with us. Commodore Maulankar, if we were to have these engines built in India, with the level of technology transfer that we seek, what would it mean for India?
So definitely the deal needs to be viewed from the perspective of the overall, it's being sold, it's being hyped really as technology transfer, but at its core, it definitely allows us access to an assured supply of engines of a very high caliber, and therefore many of our fighter programs that we currently have underway, those will definitely get a solid foundation in terms of engine availability. The blurring of lines about whether it will give us the ability to build our own engines, now that is something which will need to be seen in the fine print. So that bit is, I would think, a little bit of an extrapolation. A lot of the details that have been released that are floating around are the minutiae of of production of an engine, of the manufacture of an engine, and will that give us the design insight into being able to even, let's say, reverse engineer the engine? Will also be a function, one, of the openness, second of GE, and also the element of which agencies do we involve from our side. Mm-hmm. So if it remains HAL engine division, organizations have a particular orientation based on their primary role. So if GTRE is fully involved in it, they will approach it with a far more inquisitive approach. But if we lock ourselves up into the silos of organizations and the NDA, non-disclosure agreements, which prevent good lateral flow of information, it may not exactly turn out to be what it is being hyped out to be.
Yeah.
But bottom line, at least our current fighter programs get a solid foundation on which their success is assured.
Yeah. Samir, single crystal airfoils. Why is this cutting edge? Why is it that it's so difficult to manufacture this?
Largely, Vishnu, just to give the context, single crystal blades are something which can take on a lot of high temperature variations. That largely gives the high thrust to weight ratios what we are looking at. And the fact that GE, which is a specialist in making engines, especially lightweight engines, relies on advanced technologies such as these, is a testament to the fact that the R&D focus is clearly on technologies where you can survive high temperature regimes. Just to give you context, the temperature rise can go as high as 2000 degrees centigrade in a turbine, or close to about 1600 degrees centigrade on a kind of blade. Now, this largely, as you have mentioned before in your initial introduction, it increases the life and increases, the maintenance ability, which, goes far beyond just acquiring an engine and thereafter putting it into service. We have suffered more attrition because of Russian engines, which have lower life cycles, lower maintenance abilities, simply because, Russians have a certain architecture, the way that they design engines, as compared to what the Westerners do. And as you rightly presume, this is a very, very critical technology, which we need to induct, 404 was a direct off-the-shelf buy, but 414 is going to be based on a transfer of technology basis. What I've been reading is about 80% of TOT. And I think inclusive of all the attributes of the engine, I think largely the Indian ecosystem will gain in a huge manner. And I think whatever way we look at this, either we say that this deal may be loaded against us or going forward, I think the Indian industry is definitely going to scale up to the next evolution of platforms which can utilize lightweight engines with high thrust to power ratings and long maintenance, lower maintenance cycles with long lead life cycles.
I'd like to invite you gentlemen to stay on, because there's another key deal that the Prime Minister is expected to sign during his visit to the US. It's a $3.1 billion agreement for the direct purchase of 31 MQ-9B drones from the American company General Atomics, not General Electric, which is what we were talking about earlier. This is General Atomics. These are extremely advanced and upgraded variants of the well-known American Predator drones. What is this all about? Let's take a look.
When this drone enters service with the Indian Armed Forces, it'll bring with it an unparalleled reconnaissance capability. It's called the MQ-9B Sea Guardian. It can fly non-stop for over 30 hours. It's equipped with a host of sensors which will allow our armed forces to get real-time awareness of developments in a particular area, day or night. So for example, a variant of the Sea Guardian can be deployed along the Ladakh frontier where, from a safe distance from enemy missiles, it can provide non-stop sensor data of a build-up of Chinese forces. While deployed at vast distances out at sea, it can keep an eye, for example, on Chinese or Pakistani fleet movements from a safe distance, out of the range of the surface-to-air missiles of the ships.
The Sea Guardian has a mission radius of more than 2,000 kilometers. It can fly for 30 hours non-stop. It can be equipped with sonar buoys, which are sensors which detect submarines. It can detect enemy ships and pass off data to friendly ships and submarines, which can then engage these targets.
The deal for the MQ-9B has been in the works for years. It'll be worth more than $3 billion and would likely include 31 drones for India, 15 for the Navy, 8 for the Air Force, 8 for the Indian Army. India's acquisition of these drones comes at a time when China has positioned its most advanced Soaring Dragon drones along the frontier with India, details of which were broadcast on NDTV in a December report. China is now the world's leader in drone development after the United States. With India's acquisition of state-of-the-art MQ-9B drones, the technology imbalance which presently exists will be corrected to an extent. Vishnu Shom for NDTV.
Samir, let me just come to you about this. What does this acquisition mean for our armed forces? I spoke a lot about the Navy over there, but for the Air Force and the Army and the entire frontier with China, what would it provide our forces?
Yeah, Vishnu, MQ-9B Sea Guardian is largely a maritime-focused drone. I mean, the devil lies in the level of payloads it can carry. It's been developed by General Atomics and can fly with satellite links above weather in all kind of weather conditions for 30 plus hours. As I said, it carries a wide variety of payloads. What India has been lacking largely is persistent surveillance on its large frontiers in the Indian Ocean region. And as we recall reports that, Indian Navy Sea Guardians, the Predator 2Bs, which were used by, attachment with the Air Force also. And these were very much and very successful in kind of monitoring round the clock and giving round the clock surveillance on the northern borders. But if you see the kind of requirements that India has, it has huge, intelligence, surveillance, and reconnaissance requirements. And I think already the plethora of platforms in service, the best and the longest range of them being in service with the Indian Navy, have been utilized in all kind of scenarios where Air Force will largely now be benefit with direct induction of such drones into its arsenal, which will complement the fleet of the Herons and the Searchers, which the Air Force has. So one, the long endurance. Second is the payload. The payloads will be of many varieties: synthetic aperture radars, electro-optical, infrared, long-range communication links, and satellite links. Staying largely undisturbed, flying in a lot of unperturbed weather conditions. The Sea Guardian can also perform, a large variety of other missions like humanitarian assistance, disaster relief, search and rescue. For the Navy, it's very meaningful in terms of anti-surface and anti-submarine warfare. Long-range strategic ISR is something which, all services will be looking at, especially towards over-the-horizon location and fixing of targets and over-the-horizon targeting. And very meaningful for the Navy is going to be its anti-submarine warfare role.
Yeah.
I'm not very sure what all payloads we are going to be inducting, but it will be very interesting to see what we get as part of the Sea Guardian deal. What I can tell you and close my little thing is that it is the best drone in its class. And I think all three services are largely going to be benefited with the acquisition of the same.
All right, gentlemen, I'd like to thank you very much for being with us. I'm going to return to jet engine technology now. And I spoke a little while earlier on to R. Madhavan, the ex-chairman and managing director of Hindustan Aeronautics. Hindustan Aeronautics is going to be getting into a deal with General Electric for the manufacture of the G414 engine in India. Let's take a look at what he said. We'll leave you. Well, we've got a very special guest joining us at this stage. Mr. R. Madhavan has been a former CMD of Hindustan Aeronautics. Lovely to see you, sir. Thanks very much for being with us. Simple terms, if we build this engine in India, what does it mean for our aviation ecosystem?
It's a good news that they are trying to build this engine in India. There is a lot of scope for the other companies to join in along with HAL for the production of this aircraft. Especially this kind of engines means a lot in regards to material technology, especially the foundry part of it. So that is the area where we, and of course the machining. This is the area that we think that can be given to many of these subcontractors of HAL who can do this job and get into the latest technologies.
If you actually look at single crystal turbine aerofoils, just for the benefit of our viewers, how is that significant, and how is that technology which only a few countries have and which most countries want?
See, single crystal technology is very much necessary in today's engine, especially in the hot end components where it is required that the blade structure remains the same at high temperatures. We have a few countries which have these technologies, especially France, Russia, the United States. So there are some few varieties of these technologies that is available. India also has developed similar technologies. DMRL of DRDO has developed this technology along with HAL Koraput. So they have been trying this technology on. So the first thing that we should look at is whether we can merge these technologies with what we are getting it from the US. So that is the basic technology that is required. I'm sure that these engine design houses don't give us the technology for the single crystal production. We don't want it for, say, it requires basically a seeding element. So the seed should be what we should be capable to make it in India. So this is what we should look forward to. Just machining the final machining of a blade that is already produced is not that we are looking at. So what we are looking at is the basic foundry technologies for producing the single crystal plates.
And is it your understanding that we would be getting that?
As I understand, I don't think so.
So so this deal would perhaps fall short of what our ultimate expectations for transfer of technology would be. Is that right?
Yes. What we should look at is whether we can merge the technologies that the DMRL has developed and try to use it in the single crystals that is required for F414.
That's an important point. So based on our own technology, we would try and ultimately merge our own made in India single crystal technology for use on this engine. That's what we're looking at?
Yeah, that should be the idea.
And if so that idea
will give us the,
go ahead, sir.
This will give us the advantage that we will be able to prove our technologies on an engine of the latest kind.
And if we are able to do that, what are the implications for Tejas, for AMCA and other platforms?
See, the volume of production, that is the volume of the run that we have for engines, is expected to be around 200 to 300 engines. And the investment for such a line setup for F414 is quite huge, considering the fact that it cannot be done with the existing facilities in Bangalore, especially because of environmental issues, as well as we have a lack of space here. So it will be almost a greenfield project somewhere outside of Bangalore. It could be in Koraput, where we do Su-30 engines of the similar size. or it could be in a place near to Bangalore, which is more ideal because the end product is going to be integrated in Bangalore and in Nasik. So we should look at some other place where we will be able to do this, and because the test cell setup, which requires quite a bit of environmental issues to be ironed out. So this is where we will have to see how we are going to do it. Advantage is that if you can do it, this can be a common engine not only for LCA Mark II, it could be for AMCA as well as for TEDBF, that is the desk-based fighter that we are developing for the Navy. So this could be same. In case the Navy also goes in for F-18, the engine is common there. So the volumes are good. It should increase if we can get a contract for maintenance for other fleets who are using this engine. Then the volume will be more, and therefore it can be more economical for making it in India.
All right, Mr. Madhavan, thanks very much for joining us and explaining what that technology means for India. It is a big step forward, but is it all that it's being made out to be? Perhaps in the future it will be, but the economies of scale is what a project of this nature will really depend on. Thanks very much, sir, for being with us.